So, dear children, in this video, I will discuss about suspension. So, before going to suspension, I am giving you an example. Say, in the lab, all of you have experienced this one. Like, we have we dissolve sand in water. Okay? So, what will happen to the sand? The sand will settle down at the bottom of the beaker, and water will be above sand. So this is an example of suspension. So what is a suspension? A suspension is a heterogeneous mixture. Do you remember heterogeneous mixture? What were the points? In heterogeneous mixture, the particles can be seen properly, right? They can be separated easily. Then the size of the particles are bigger and they are usually unstable, meaning they settle down when you let them undisturbed. Here is a heterogeneous mixture in which the solid particles do not dissolve but remain suspended throughout the bulk of the medium. So, example is sand in water, chalk powder in water. So, suspension normally does, in case of suspension, say chalk powder, when we are using chalk powder does not dissolve in water. So what it will do, it will be suspended in the whole of the medium, right? What is the medium here? Medium will be your water. Then comes properties. So what are the properties of suspension? It is usually a heterogeneous mixture. So particle size are bigger. How much? It will be more than 1 nanometer. Do you remember for solute, what was the value? It was less than 1 nanometer. So, the size of the particles are bigger, so you can see the particles with the naked eye. I think all of you have observed when we put sand in water, what happens is you can see the particles of sand, you can say disperse or in the whole solution. Then comes the particles can be separated by filtration. This you have done in lower classes also. Why they can be separated by filtration? Because the size of the particles are bigger than the pores of the filter paper. So what will happen? The filter paper will not allow the particles to pass through them. For the next point, particles settle down when left undisturbed. That is, suspension is stable. Meaning, when I will put a solution of sand in water, if I keep it undisturbed, I will find that the sand particles will settle down at the bottom if I keep it undisturbed for some time. So, what we will say, we will use the word unstable. So, one new thing you have learned, that a particular solution will be unstable when the particles settle down when left undisturbed. So, do you remember in case of true solution, the particles does not settle down when left undisturbed. So, true solution was stable. Clear? Then comes particles are big enough to scatter a beam of light passing through it. That is, they exhibit what effect? Tyndall effect. Tyndall effect means it is a scattering of a beam of light through the solution. So, in case of solution, what was the point? The particles are smaller, they completely dissolve in water, so they do not exhibit Tyndall effect. But in case of suspension, they will exhibit Tyndall effect. So these are the points you have to remember. This portion will be your definition. These are examples and these are your properties. Total, how many points? 5 points. Okay, clear? I think so. Refer to your book and read from there. So whenever school will resume, I will show these things in the lab. I think you have to do a practical also based on this suspension and true solution set. Another topic will be there, colloids. Yeah, thank you.